Welcome, class. Today we're going to talk about rational linear equations, proportions, and inequalities. You should have turned your homework in for day 7, and so the substitute will hold on to that until I return, and then we'll go over the answers to day 7's homework. But please do turn that in today. All right, starting with rational linear equations. The first problem says solve for x. X over x plus 8 equals 7 over 15. This is a proportion, and a true proportion is one fraction equals another fraction. And so we solve that by cross multiplying. So x times 15 is 15x, and that equals 7 times x plus 8, or 7 times the quantity x plus 8. Please don't forget, if you have more than one term, to put it in parentheses. Distributing on this side gives us 7x plus 56, and we can carry down the 15x. Subtracting 7x from both sides gives us 8x equals 56. And of course, when you divide by 8 on both sides, you'll get x is 7. Now, you might want to go back and plug that in to check, but that will be the solution. All right, in example 2, we do not have a proportion. We have two items on one side and one item on the third, so you cannot solve it by cross multiplying. Instead, we use the least common multiple method. And what I want to do is focus on the denominators. So both denominators together, their products, will make my least common multiple. So if I were to go back and rewrite this equation as something divided by 6x in every term, what I need to do is say, well, I didn't have anything in this term, so I had to add the 6x on the bottom. That means I have to add the 6x on the top, because 6x over 6x just goes to 1, and that term would still be x. Now on this one, I already had the x, so the only thing I had to add was the 6. So that means I have to add a 6 multiplier on the top as well. And in this term, this last term, I had a 6, so the only thing I needed to do was add an x. So on the top, I'm going to multiply by an x, because x over x goes to 1, and I'm left with 25/6. Okay, now what I have is common denominators for this problem. And since all of the denominators are the same, I'm going to ignore the denominators and simply solve the top equation. 6 times x is 6x squared, 6 times 4 is 24, and 25 times x is 25x. Now I'm going to subtract 25x from both sides, and you'll see why in a minute. Because this gives me a quadratic equation stopped writing. Oops. So sorry. That can be solved using the quadratic formula. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. This is my a value. This is my b value, and this is my c value. So if I plug those in, I get a negative b plus or minus the square root of b squared minus 4 times 6 times 24 all over 2 times 6. And simplifying gives me 25 plus or minus the square root of 49 over 12, which gives me two solutions, 8/3 or 3/2. You want to check both, and you will find that both of them solve the original equation, so both of them are correct. Okay, solve for x given that the quantity x times 2y minus 12 plus 36 is x times 2y minus 8. Most people would say you can't solve this because there's only one equation with two variables. Let's go ahead and see what happens when you resolve the terms. X times 2y is 2xy. X times negative 12 is negative 12x plus 36. X times 2y again, 2xy. And x times negative 8 is negative 8x. Now, if we were to notice that both the 2xy occurs on this side of the equation and this side, we could cancel them out, because subtracting 2xy from both sides just gives us 0. Bring down the negative 12x plus 36 equals negative 8x. And I'm going to move the negative 12x to the other side by adding it to both. And I get 36 equals 4x. So x equals 9. Okay. This could not have worked if the xy term did not cancel out. All right, and this one is much the same, only this time we're going to use the FOIL method. We're going to do first terms, outer terms, inner terms, and last terms for both sides of the equation. So, x times x is first terms, that's x squared. Outer is x times 1, or 1x. Inner is negative 4 times x, or negative 4x. And last is negative 4 times 1, or negative 4. On this side, x times x is x squared. X times negative 5 is negative 5x. 5 times x is 5x. And 5 times negative 5 is negative 25. Now, I'm going to simplify first the left side of the equation, and I get x squared minus 3x minus 4. And then the right side of the equation, and I get x squared minus 25. And again, notice, the x squareds occur on both sides of the equation. So if I were to subtract x squared from each side, they go away. And now I have negative 3x minus 4 equals negative 25. Adding 4 to both sides, I get negative 3x equals negative 21. So x is a positive 7. And example 5. Again, this is an LCM problem, very similar to the one we did earlier. So this time my denominators are 3 and x plus 3. So what I'm going to do is I'm just going to begin to change the equation as it's written. Well, I already have an x plus 3, but I needed an additional 3 in this denominator, therefore I add it to the numerator. Here I already have a 3, but I need an x plus 3, so I'm going to add it up here as well. And over here, I have neither 3 nor x plus 3, so I need to add both of these to this numerator, the 3 and the x plus 3. And now check. All of the denominators are equal. And so because they are, I can scratch through them and simply solve the numerator portion of this problem. 10 times 3 is 30. 10 times x plus 3 is 10x plus 30. 6 times 3 is 18. 18 times x is 18x. And 18 times 3 is 54. And again, 30 and 30 is 60 plus 10x equals 18x plus 54. I'm going to take 54 off of both sides. And I get 6 plus 10x equals 18x. Now I take 10x off of both sides. And it looks like 6 equals 8x. And so x equals 6 over 8, or 3/4. And you can plug that back in and prove that that works.